Hello, this is Professor Brown-Cedarberg, and we're going to be looking at searching algorithms. Now, searching algorithms are algorithms that determine if a value, we'll call that the search key, is in a given data set. If it is, the location of that value in this data set is returned, the index. If not, a value that signals the failure to find the search key is returned, and that value is typically -1, because -1 is certainly not a valid index value. We're going to look at two common search algorithms, the linear search and the binary search. Now, a linear search is very easy to understand because it just starts at the beginning of an array and continues through that array sequentially, searching each element of that array to see if it finds the value it's looking for. A linear search works in O(n) time, and a linear search can be used if an array is sorted or not, so there's no prerequisite that the array be pre-sorted. Linear search works on an unsorted or sorted array, and it just begins at the beginning and goes through. And so here's the implementation of a linear search algorithm, and this is using a method that we'll name linear search. It returns back an int, expects an int, we'll call that key, that's what we're looking for, and an array of ints, the array to search, that's what we'll be looking through. And so we just have a simple loop with I given a value of 0. We'll continue through this loop as long as I is less than the length of the array we're searching, and we'll increment I each time we go through the loop. And we'll simply ask the question, is what we find at position I equal to the key? If it is, I return back I, my method ends. If not, I continue through the loop. If we go through the entire loop without finding that key, what we're looking for, in that array we're searching through, we'll return back -1. That's a very simple algorithm. It's the linear search. And if we were to demonstrate it here, we're looking for 21, and here I happen to have a sorted array. I don't need the array to be sorted, but we're looking for 21, and so we'll just begin at the 0th position and go through the elements until we find, and in this case we do find, the value 21, and we return back the value of I, the position 21 was found at. Here I'm looking for 55 within that same array, and I'll just begin at position 0 and continue through the array looking for that key, that 55, and here I don't find it, so what's returned back is -1. So that was a linear search. Let's look at a binary, and a binary search is a little more complicated, but it's most easily understood as just divide and conquer. What it does is it looks at the middle element of an array. Now, in a binary search only works if the array has been sorted, and it has to be sorted in ascending order. So this algorithm compares the key, what we're looking for, to the middle element of the array. If I find the value I'm looking for, the index is returned back. Otherwise, right, if the key is less than that middle element, the algorithm searches the subarray to the left of the element. If it's greater, it searches to the right. And the algorithm just continues to repeat this until the key is found or there aren't any more elements to look at. If it doesn't find the element, it returns back -1. So it finds the middle element, says, is it greater than less than? I go to the left or the right and search that subarray, and just continuing the process. So let's look at this, remembering that an array has to be sorted in ascending order for the binary search to work. Binary search operates in O log n time. That's its efficiency. So here we've got a method that implements a binary search. And so we see that this method expects an array of ints, we'll call that array to search, and an int to be passed into it. And that int is the key, that's what we're looking for. So we'll establish 3 int variables, start, end, and middle. Start, we give a value of 0. End, the value assigned to it is the length of the array we're searching, -1, and middle doesn't have a value yet. We'll go through this while loop as long as start is less than or equal to end. That is, there's something to search through. And so we'll give middle a value. We'll take the value of start, the value of end, divided by 2. Now this is integer division. Remember, start and end are both ints. So I add those two, divide it by 2. I'm going to get an int back, which means I truncate. So I take the start and the end, divided by 2, that goes into the space middle. And I look at the space that is indexed middle, and I see if it's equal to the key, what I'm looking for, if what's stored in that space is equal to the key. If it is, I return back the middle. Otherwise, I test, is the values found in that middle, in that index middle, less than the key? If it is, I reestablish the value of start, I make it middle plus 1. Otherwise, I reestablish the value of end, I make it middle minus 1. And I continue through this loop as long as there's something to search. If I find what I'm looking for, I return it, the method's over. That's that return middle. Otherwise, I return back -1. So let's see how this one looks. Here I've got an array. It is pre-sorted, and it is odd numbered in length, that there are 9 elements in it. My key is 3. So I'm looking for the value 3. Right? So I establish the value of middle, which is I take the start and the end. That's 0 and 8. I add those two together, divide by 2, that gives me 4, and I establish middle as the value 4. And I say, is that equal to what I'm looking at? It's not. But in this example, I see that what's at that middle, at that position 4, is greater than what I'm looking for. So I throw away what's to the left of that middle within my array, and I look at the subarray that's to the right. I then reestablish the value of middle with start plus end. So that's 0 plus 4. I divide that by 2. That gives me 2. So I look at what's at position 2, and in this case, it's 6. That's greater than what I'm looking for, 3. So I throw away what's to the right of that, and I looked at the subarray to the left, and that's 1, 3, and 6. I reestablish middle with start plus end. That's 0 plus 2 divided by 2 gives me 1. I look at what's at position 1. That's 3. That's the key I'm looking for. My search ends. Here I'll have an array that has an even number of elements. And this is where that integer division comes in. So I establish the value of middle with start plus end. Now start is 0, end is 7, so I get 7 divided by 2. That gives me 3.5. I'm going to truncate that to 3. So establish middle to have a value of 3. So I go to the position in my array that is position 3. That's occupied by the value 5 at this point. Remember, I always start indexing at 0 in my arrays. So my middle has a value of 3. It's occupied by 5. That's greater than what I'm looking for. So I reestablish the value of middle by start plus end, 0 plus 3 divided by 2. That's 1.5. I truncate that to 1. My middle is therefore established as 1, and I point to the value in the index 1 position. That's the value 2. Now that's less than what I'm looking for. Where 5 was greater than and I threw away everything to the right, here 2 is less than, so I'm going to throw away everything to the left of middle. I'm going to reestablish the value of middle with start plus end. That's 0 plus 1 divided by 2. That's 1/2. That truncates to 0. So my middle is now the 0th position. That has the value 3. I've found what I'm looking for. So what we've examined today are 2 search algorithms, the linear search and the binary search. Linear search is sequential. Start at the beginning, go to the end, or go until you find what you're looking for. Binary search is divide and conquer. Establish that middle position, look to that value, throw away what's to the right or to the left, depending on how your evaluation works out, what that middle value is relative to what you're searching for. Linear search, you do not need your array to be sorted. Binary search only works if your array has been pre-sorted and it's sorted in ascending order. Thank you very much.